my dear students. My name is Sharma, working as physics lecturer in one of the reputed institution. Today, our concept is about simple harmonic motion, SHM. Okay? So one of the important concept for all competitive exams. Okay? So we'll take some examples about SHM. So this spring mass system that is moving up and down, okay, comes under SHM, or else a simple pendulum. Okay, so it is also SHM. Liquid that oscillating in U-tube is also SHM. So what is simple harmonic motion? So remember, whenever a body executes simple harmonic motion, acceleration of the body is always proportional to displacement in opposite direction. Okay? Now we are going to know in detail about SHM and how we find its displacement and all. Okay, so let us assume a circle of radius A called a reference circle. The purpose of this circle is to find the displacement of a body when it executes simple harmonic motion. Okay, so consider a particle which is moving on the circumference of a circle. Okay, now we are assuming one particle which is moving along the circumference of a circle of constant angular velocity, say omega. Okay, constant angular velocity omega. Suppose the particle is at this point, say makes an angle pi called phase angle. Means in the beginning the position of the particle is at this point, say pi. Say it reached to point P. It reached to point P, say in time t seconds. So the particle is at this point, reached to P, say in time t seconds. So in the beginning, with reference to this x-axis, it is making an angle pi. After t seconds, it is on this point. Okay. Taken time t seconds. Okay. Now, how to find displacement of the body when it is projected on the diameter of the circle? Okay, this one or else this one. So you can notice that these two are perpendicular. So we have drawn two perpendicular diameters, x dash o x or y o y dash, or two perpendiculars. Okay, so when the particle reaches to this point, now taking t seconds, so within the same time the particle which is moving on the diameter of the circle reaches to m. So this particle m is moving on the diameter. Okay, so reach to m, taken t seconds. So this reach to n, taken t seconds. So this particle is moving on the diameter of y-axis. This one along x-axis. Okay, suppose capital T be the time period, means time taken by this particle to complete one rotation. Okay, so angular velocity, you know 2 pi by t na, so t becomes 2 pi by omega. So when this particle which is moving on the circumference of circle takes t seconds to complete one rotation. By the time the particle which is moving along this x-axis takes t seconds to complete one oscillation. So this particle m takes t seconds to complete one oscillation, or else this particle n takes t seconds to complete one oscillation along y direction. Okay. So let us assume the particle is at point P. So in the beginning it is at some angle. Okay, pi. When t is 0, called phase angle, and taken t seconds to reach this point P. Okay. Now how to find the displacements? Okay. So when the body executes SHM. Okay. So by dropping the perpendiculars, okay, this one, say x, OM, okay, OM, okay, so you know, this is the total angle, P, M, O, theta. So total angle is, you know, omega t plus pi. Okay, so you want this part, OM. Okay, so cos theta is equal to adjacent by hypotenuse now. So you can take OM by OP. OM, take it as x. OP, radius na A. Okay, then you get x equal to a cos theta, or else you can write a into cos of omega t plus pi is x. So the displacement of the particle when it is projected on the diameter of this circle is x equal to a cos of omega t plus pi. Okay, now about vertical displacement. So if you drop another perpendicular now, so this will give you vertical displacement. So take it as y. Okay, O N P. So if this is theta, this is also, you know, theta. Alternative angles now. So from here you consider sine theta equal to opposite by hypotenuse, no? So y by a. Okay, so y is equal to, you know, a sine theta, nothing but, you know, a sine omega t plus pi. So when the particle is projected on the diameter of the circle, say along x direction, this is the displacement, a cos omega t plus pi. So when the particle projected along the diameter of circle in y direction, it is a sin omega t plus pi. So in order to know the displacement of the particle when it is projected along x or y, we are taking this reference circle. So what is the purpose of this reference circle? Mainly useful to find displacement of particle when it is executing SHM. Okay, now we are going to know velocity, acceleration and energy of particle when it executes SHM. Now, so you know, when a body is executing SHM, its displacement in horizontal direction is x equal to A cos omega t plus pi, or y is equal to A sin omega t plus pi. So this is displacement of the particle when it is projected on the diameter of x-axis of the circle, right? Or this is displacement of the particle executing SHM in diameter of circle in y direction. Okay, now displacement. So followed by it you can find velocity and also acceleration. So whenever displacement is differentiated now with respect to time, you get velocity, right? So differentiating this equation with respect to time, okay, so dx by dt equal to velocity now, which is equal to a into differentiation of cos, you all know it is minus sin now with respect to t. We are doing, you must have studied in differentiation chain rule. So omega into 1 plus constant value 0. No, differential value of constant is always 0 now. Now, so velocity equal to, you can write minus a omega sin omega t plus pi. Okay, or see, cos omega t can also be taken as only cos omega t plus pi, okay, is taken as x by a now. Now, so sin can be taken as under root of 1 minus cos square theta now. So you can write 1 minus cos square omega t plus pi, right? So you can also write a omega of 1 minus x square by a square now. So further you simplify, you get omega root over a square minus x square, okay, so with negative sign. So that sign indicates only direction. So velocity of the particle is omega into root over a square minus x square, okay, or you can write a omega sin omega t plus pi, okay. Now when it is further differentiated, so whenever velocity is further differentiated, you get acceleration now. So differentiating this equation again with respect to time. So a omega constant now, differentiation of sine, cos omega t plus pi with respect to t you are doing, so that is why omega into 1 plus 0, okay. So this will give us acceleration. So acceleration is equal to, okay, minus a cos omega t plus pi can also be taken as x now. So omega square x. Omega is constant, no? So that is why acceleration of the body is directly proportional to displacement in opposite direction. So this is one of the necessary condition for a body which executes SHM. Remember, acceleration is always equal to minus omega square x. Okay, so whenever a body executes simple harmonic motion, only when acceleration is proportional to displacement in opposite direction. Okay. Now about energy of particle which execute SHM. So now we are going to derive total energy of a particle executes SHM. So you know, displacement of a body execute SHM is given as x equal to a cos omega t, otherwise you can take a sin omega t also. Now let us consider a particle executing SHM, displacement given as y equal to a sin omega t. Okay, a sin omega t. So whenever you are differentiating, right, with respect to t, you get velocity na dy by dt. So a differential value of sin cos omega t na with respect to t you are doing, that is why you get into omega. So this is velocity of the body which executes SHM. So let us assume mass of the particle be m. Then its kinetic energy, you know, half mv square na, that is nothing but you know half m into, okay, a square omega square cos square omega t. So this is the kinetic energy of the particle. Okay, now you want to find potential energy of the particle. So actually you know the displacement of the body is y. For our convenience, let us assume it is at zero displacement in the beginning. In order to move to y, total work done in the process itself is equal to you know its potential energy, right? So work done in displacing up to y units is potential energy. You know, work done is always force into displacement na, force according to Newton's second law ma, right, dy. But what is the acceleration of the body? Omega square y. No? So whenever a body executes SHM, what is formula for acceleration? Omega square y with negative sign indicates direction, right, and dy. So this is the small work done, no, small work done. But you want to find work done in displacing from 0 to y, right? So when you integrate on both the sides, you know, m omega square y dy, right? So total work done or potential energy, no, is equal to m omega square as it is now, integral y is you know y square by 2, because power is 1 na, x power n plus 1 by n plus 1, or here 1 no, 1 plus 1 by 1 plus 1. So y already know a sin omega t. Therefore potential energy is equal to you know half m omega square, okay, a square sin square omega t plus pi. So this is potential energy of harmonic oscillator, this is kinetic energy of harmonic oscillator. Okay, you want to find total, no, sum of kinetic and potential only now. So sum of kinetic and potential will give us total energy. So total energy is kinetic plus potential. Kinetic half m omega square a square cos square theta, or here sin square theta. So you know trigonometric identity, sin square theta plus cos square theta 1 na. So that is why total energy of harmonic oscillator will become half m omega square a square. Okay, so that is about energy of oscillator. So remember, whenever a body executes SHM, Okay, acceleration is always proportional to displacement in opposite direction. So based on this concept, we'll do now problems also. Now you have given a problem. Problem is there is one particle executing SHM. Its frequency is known to us, 12 Hertz. Okay, and they have given the particle amplitude is 4 centimeters and its initial displacement is 2 centimeters in the positive extreme position. So it can be taken as Y. Okay, positive extreme position, initial displacement is 2 centimeters, amplitude 4 centimeters. So in order to find the displacement of a body executing SHM is given by an equation y is equal to, okay, a sine omega t plus or minus pi. Over here it is given positive extreme position. So that is why phase angle you can find when t is 0 na in the beginning. Okay, so taken plus, and in the beginning you want to know phase angle pi. Okay, so according to problem, displacement 2 centimeters, amplitude 4 centimeters, right? This is 0 na plus pi. So sine pi equal to 2 by 4, nothing but 1 by 2. So angle becomes pi by 6, right? So phase angle is known to us. Omega, angular velocity na, so that can be taken 2 pi n or 2 pi by t, depends on the problem. Over here frequency is known to us, so we can substitute. Okay, so 24 pi. Okay, amplitude given in CGS units, you can convert into meter. Okay, therefore equation becomes 0.04, 4 centimeters now, so 0.04 meter. Sine omega 24 pi t plus phase angle in the beginning. So the initial position of the particle when t equal to 0 gives phase. No? Now about the given problem. The problem is there is one particle executing SHM, its acceleration is given. That is a plus 16 pi square x equal to 0. Okay, take this to other side. It is minus 16 pi square x now. So whenever a body executes SHM, its acceleration is equal to omega square x. Remember, so whenever a body is executing SHM, what is general formula for acceleration? Minus omega square x. Now when you are comparing these two equations, in place of omega square you have given 16 pi square, right? So you can write omega square itself is equal to 16 pi square. Okay, then omega 4 pi. You want to find time period. So whenever you want to find time period, you always take omega as 2 pi by capital T. So which is given as 4 pi, right? So pi cancelled. 2 divides 4 2 times now. Therefore time period is equal to half second. Okay, half second. Now about the given problem. So there is one particle executing SHM. Its displacement given as x equal to a cos pi t by 2. Okay, so you want to know distance traveled by the particle from 0 second to 3 seconds. Okay, so first of all you should know how much time it will take to complete one oscillation, one vibration. So omega is equal to pi by 2 now. So that is when you compare the given equation with A cos omega t. That is when a body execute SHM, displacement taken as A cos omega t now. So comparing omega taken as pi by 2. So omega you can write 2 pi by capital T now. Pi cancel. So time period becomes 4 seconds. Okay. So time taken from 0 to 1. No? 0 to 1. See in the beginning. If you take this as 0 now, x equal to a. Right? X equal to a. So distance traveled from 0 to 1 second is a. 1 to 2 seconds. Another a na? 2 to 3 a. So total distance traveled is 3a. Now about the given problem. So in this problem you have given a particle executing SHM, its displacement also we have given. That is y equal to 10 sine 3t plus pi by 3. Okay, under this you have given two questions. What are they? One is initial displacement. So initial means in the beginning. That means t must be taken 0 now. So remember, whenever you want to find initial displacement, simply you put t 0. So if you put t 0 in this equation, you get initial displacement. So 10 sine, this is 0 now, pi by 3. So sine 60 degrees value is root 3 by 2 now. So 2 divides 10 5 times. So 5 root 3 meter. Okay. So that is about initial displacement. What is second question you have given? Maximum velocity. No? So maximum velocity equal to a omega. That is omega root over a square minus x square now. So maximum means in the beginning. So a omega. No? So a 10. Comparing the given equation, a is 10 now with a sin omega t plus pi. So a 10 units. Okay, omega 3. Right? That is you are comparing the given equation with a sin omega t plus pi. So a 10 omega 3. Right? So 10 into omega 3. Okay. So 30 meter per second is the maximum velocity. Now about the given problem. That is, you have given that there is one particle executing SHM and its velocity given root over 144 minus 16 x square. So you want to find maximum acceleration. That means acceleration of the particle at extreme position only now. So first we have to compare the given equation with velocity at any point. So you can write this 144 16 multiple no 9 minus 16x square. So 16 you can take common. So 4. No 9 taken as 3 square now x square. Okay. So velocity equal to omega into root over a square minus x square now. Omega 4 a 3. Okay. So maximum acceleration is omega square a now. Sign indicates only direction. Okay. So omega square 4 whole square into A 3, right? So 16 threes 48 meter per second square. Okay, so maximum acceleration is 48 meter per second square. The maximum displacement of a vibrating particle is given in this problem. Okay, so maximum displacement means nothing but amplitude only, so y max is given, okay, that is 0.05 meter. Okay, time period is also given 1.5 seconds. So you have to find the velocity at mean position and acceleration at extreme position. So velocity at any point omega into a square minus x square na, but you want in the beginning. Mean means starting na, so x taken 0, that means you get v equal to omega a. Omega can be taken 2 pi by t na, that is 1.57 na, into amplitude, that is also known to as 5 by 100. Okay, so pi is actually 3.14 na, so 3.14 divides 1.57 2 times na, so 4 5 is 20 by 100, cancel now, nothing but 0.2 units meter per second. So this is about velocity at mean position. Now you want acceleration. So when a body executes simple harmonic motion, what is general formula for acceleration? A equal to minus omega square x, right? So this sign indicates direction, so that you need not consider now. So x is displacement. So here you want at extreme position, nothing but amplitude only na, so minus omega square a na, so omega square a, so omega taken as 2 pi by capital T whole square into amplitude na. Okay, now 2 pi by t, pi you can take 3.14, time period 1.57 whole square into amplitude 0.05, or you can write 5 by 100 also, right? So this divides 2 times na, 4 square, nothing but 16 na into 5 by 100. Okay, so 16 5 is 80 na, so 0.8 meter per second square is acceleration. Okay, now about the given problem. A particle is executing SHM. Its time period is given as 12 seconds. Okay, so you want to find time taken by the particle, okay, when its displacement is equal to half of the amplitude. So what is your given question? Time taken by the particle when its displacement is equal to half of the amplitude. Okay, so y is equal to a sine omega t. So at an instant its displacement is a sine omega t. But according to problem, displacement given as half of amplitude na. So a sine omega t. Okay, a cancelled. Therefore, sine omega t equal to half. When the sine value becomes half, that is when sine 30 degrees if you take now, you get half, no? So pi by 6. So you can cancel sine, right? So omega t is equal to pi by 6 now. Omega, you can write 2 pi by t na time period into small t, which is equal to pi by 6. Okay, so pi cancelled. According to given problem, time period is 12 seconds now. So 6 divides 12 2 times, and this 2 also gets cancelled, right? So t becomes 1 second. Okay. Now about the given problem. So two particles which are executing SHM, their amplitudes ratio is given as 1:2, and they said they are having equal energies. Okay, so just you want to find the ratio of their frequencies. So you have given two particles. So total energy of a particle executing SHM is given by half a square omega square m na. So here two particles are having equal masses and equal energies. So you can write half a1 square omega 1 square m equal to half a2 square omega 2 square m half of cancelled. Okay, so omega 1 square by omega 2 square is taken as a2 by a1 whole square. Okay, so you can write omega as 2 pi n na. So 2 pi n1 by 2 pi n2 equal to, you can write a2 by a1. Okay, so 2 pi cancel. According to problem, a1 is to a2 is 1:2. Therefore a2 is to a1 2 by 1. So ratio of their frequency is 2:1. Thank you for watching this video. Please subscribe, like, share, forward to your friends. Thank you.